Hi, everyone. I'm Steve Brudz. I'm a principal engineer at Def Method, and I've been working on Phoenix, which is our AI-powered QA tool for Ruby on Rails applications. I guess it was March of this year, I gave a talk at this meetup showing sort of our progress to date on Phoenix, which was really focused on the test generation part of things and generating lots of tests at scale. And in the intervening time, we have built infrastructure around it to do orchestration and automation of that test generation. So that's what I'm going to show you here today. And there's three key concepts that I'm going to introduce: monitoring, Everflame reports, and self-healing. And I can't say like they're entirely novel, but they're not probably things that people encounter in their day-to-day work. So I'm going to go through and explain each of these as we go along. But let's meet the hero of our story. So this is Maple. She was hired by Cat's Paw LLC as the CTO to help clean things up. And Cat's Paw LLC has a number of problems that sort of the classic issues you hit with when you have technical debt in your code base. You've got sales complaining that customers are pissed off and threatening to leave because releases are buggy. The head of product feels like engineering's slow, and then you talk to engineering and they're like, "Oh, this code's a mess, and I didn't write this. I don't want to work in it." And so Maple takes a look at one of their systems, which is their blog. And it's a Rails application. It's got, 64.5% test coverage. Not great. There's definitely some holes, but there are some tests. And so Maple decides to bring in Phoenix, which is our active agentic QA system to provide some peace of mind for every release of your Rails app. And so I'm going to do a mix of video and actually showing the live app, in part because some of this stuff takes time. So Maple is now activating Phoenix on that repo. And coming in here, I'll show you this page in a moment. And so Maple selects a bunch of methods to monitor, and then Phoenix goes off and starts generating tests for each of those methods. And you can take a look at the test code that was generated, and it's covering different use cases. And let's see, I'm going to pop out of this for a second. So yeah, here's the monitoring page. So right now, you can select everything. You can just choose sort of some of your higher flog score methods to generate tests for, depending upon where you want Phoenix to be looking at. And then if we actually look into the tests that were generated, this is, I think, what I demoed back in March. We've made some progress at kind of enhancing it to follow RSpec best practices. So controller tests, are, sort of general RSpec. We're using FactoryBot to generate the test data, and then we're mocking where needed. Let's see. And so when we generate tests here, what's actually happening behind the scenes? So Phoenix tests are owned and maintained by Phoenix. They never move into your own repo. So this green GitHub repo, this is the Cat's Paw LLC demo. When Maple activated the repo, Phoenix created a shadow repo in our own private GitHub organization and that mirrors the code. And when Maple chose some methods to monitor, Phoenix went and generated tests and stored those in the shadow repo. And we've chosen to start with breaking the whole system, all the code down into a method-by-method basis. And then we're monitoring each of those methods with the tests. And one way to think about that is those tests form the baseline contract for the system. They're kind of defining that behavior. Now, if you were a human thinking about it like this, yeah, that's what it does, but every time I make a change, I have to update my tests to match. So Phoenix has a slightly different way of doing that, and I'll talk about that in a moment. I'll say a word about the test generation process. This is the same slide that I showed back in March, almost, but it's the same core engine that we're using. So we're doing some initialization, some indexing, some analysis of the project, and then we're creating a structure for the test and going through and this sort of looping process of running the tests, fixing issues. We also have guardrails that apply, like Rubocop rules and whatnot. And once all the test generation is done, we run those test cases and send the data back to Phoenix. So the next thing Maple does is she decides to change some business logic. And so, actually, let me pause this and full screen it so you can see a little better. So this PR is, they have an admin role that's existing, but now the requirement is to add a super admin role in addition to the admin role. And so the first small step that Maple takes is that she is changing the existing admins into super admins, and then later she'll add the original admin, the new like lower powered admin functionality. So the tests all pass in the PR. Maple feels good. All right, she merges. Phoenix runs, let me just take a step back here. Phoenix brings in those changes and notices that, oh, you've got some failures on main. We'll look at that in more detail. So actually, I'm going to show you this in a second. We also send out an email saying, hey, we found some failures, alerting your team. And with this is what we call Everflame. So a change is committed to main into the GitHub repo. A webhook has Phoenix synchronize those changes into its shadow repo. And we run that Phoenix test suite against that new commit. And so now we're running the old tests against the new code, and we're going to have failures because you almost invariably made some change in the behavior. But what we want to do with Phoenix is we want to analyze those failures to determine, were those intentional? Did this PR actually change the contracted behavior, or is there some bug that something you missed that was causing those test failures? And so this is the triage process. So Maple, let me go back here. There we go. So Maple sees her Everflame report, and she starts to look into each of those failures. And this one here, she's noticing, okay, it says it's expected. This is the logic that I changed. All right, let's go on to the next one. All right, this one has sort of a potential bug. And this one here, wait a second. The role change from admin to super admin might not have been fully incorporated into the authorization checks. Let's take a closer look at this. And Maple takes a look at the source code and notices that there's a hard-coded admin check in this post policy. And so that is a bug. Maple didn't update that in her code. And so she marks each of these items, and she sort of digs in more as, hey, I found an issue for these. And now she takes a look at this last one and noticing that, okay, for the user policy, I actually did update the super admin, or the role to be super admin. So we're good there. That's probably just a change in the contract. So Maple goes ahead and marks that as heal tests. And so Phoenix goes and actually fixes those tests. Let's see if there we go. So this is the self-healing process. So if when Maple marks something as issue found, that's saying, hey, I need to fix this on the main branch. A human is in the loop, got to take care of that. When Maple marks something as, hey, heal these tests, that triggers Phoenix to generate basically new tests for that same method and run the test suite so that we know that, okay, this is now fixed, and it updates the Everflame report. And so the final step, she's found a bug, and actually, wait, let me pause here. Go back. So Maple creates a pull request to fix the post policy. And so she's going in and updating that particular policy, puts the PR together, a very sped up run of all the GitHub Actions stuff. And then when she merges it back in, Phoenix detects that new commit, and Maple can pull up the Everflame report and sees that everything is green. And Phoenix, for this repo at least, has generated 97% line coverage and similar branch coverage. Let's see. So what does this mean for Maple? So Phoenix caught a bug before it went out into production, which that reduces customer frustration. And this sort of I guess it's like a safety net underneath the tightrope walker. It helps teams, supports them in addressing technical debt, and lets the teams focus on delivering value and not fighting fires. And so I mean, one of the things that we've been building this. We've got a few early stage beta partners. We're looking for more people to try it out, give us feedback, and we'll be doing a public launch very soon. But how would an AI agent maintain test suite change your workflow? If you have a legacy application with, I don't know, maybe it was 10 years old and it's still in use, but no one really knows the code, and you need to upgrade to the latest version of Rails or some other gem. It's the ability to say, oh, I just want to generate tests for this whole swath of the application and have those maintained, and I don't have to think about it. Or if you're someone who test drives your code and is always, at 95% test coverage, I don't know, it may not be the sweet spot, but at least we tend to do that when we develop with Phoenix. We have very high code coverage, but at the same time, like it's an extra layer underneath of protection. So if the higher value of what your system's doing, like the higher the risk of a failure, I would say that the more likely you want more safety nets underneath you. So as I mentioned, our public release is coming soon. And Joe Leo, would you raise your hand? If you talk to Joe and say you're interested, you will get free credits. So thank you, everyone.